Okay, so I will be discussing all the problems and the solution I wrote. So now let's move to the first problem. First of all, let's have the answer. Okay, so now the first problem is sum of 3. So we have been given an integer n and we need to find three integers x, y and z. Those three integers should be distinct and none of the integers should be divisible by 3. So we have to find that any triplet which satisfies these two conditions. Now as we can see, like here, uh, I'm now to get the three integers, let us assign the minimum value which is possible to the minimum first two integers. Like in like the first integer can be 1 and second integer cannot be 1 because we need distinct, so it can be 2 and both of them are not divisible by 3. And if and the remaining would be n minus 3 because the sum of them is 2. Now if this is divisible by 3, then we cannot have the answer, and if it is not divisible by 3, then we can say that they are all distinct and this should be distinct from the first two. So they are all distinct and the sum of them is n. Then we can output this answer which we have did in the first step. Now the second condition is uh, we can have one, but we cannot, like the approach goes as like this. We can have a number mod 3 equal to 1 and number mod 3 equal to 2. Both of the case will be for the first two numbers. Okay, so okay, so now we can we can have a different combination of these two things, like the mod. This can also work, this can also work, and this can also work. So we need three pairs which satisfy these conditions, these three conditions. So the minimum values which satisfy these three conditions are these three. The first one, the mod of them is 1 and 2. The second one, the mod of them is 1 and 1. And the third one is mod of them is 2 and 5. uh, in these cases the mod is 1 and 1. We cannot have the second integer as 1 because then it won't be distinct. So we uh, 4 is the uh, least value which has mod 1 and it is not 1, and similarly for 2 and 5 case. So we can have these conditions and we can return the answer. Now the third problem is interesting. The problem statement says that we are at our office, that is we are currently at our office and we need to go to the home, but it's dark at night. So the monocarp wants to go through the home in the uh, light only. So there are two lanterns are given at point A and B, lanterns at point A and B with the coordinates are given, and the home of the person is at Px and Py and the office is at 0 and 0. Now we need to find the minimum value of minimum radius of both the lantern, that is the radius for them both of them should be equal. The minimum radius such that monocarp can go home in light only. Now to do that, there are three like the first we can think of is the first way we can think of he can go like if both of his home, like his home and office, are in one uh in like one circle, we can say, like the radius. So if both of them lies in one, like in the C1 or C2, both of them lie in the one circle, then we can say that he can obviously go to the his home. But if it is not the case, no, but if it is not the case, then we need to join both the lanterns, and the home should be in one and the office should be in another, and they should be connected like this, like the distance they should not be, there should be a path from one circle to the another, then they can like go to the home. So for that we need to check those two conditions, like we need to check if they are in the same home and office are in the same circle, or if they are not in the same circle, then they should be in one of the C1 or C2 circle. So now to find the radius, what I have done is like we have taken the office is at 0 0, the home is at I have taken the home input, and I have taken the coordinates of the lanterns. Now I am doing binary search on the radius, and as the radius can be in the could be can be in decimal, so I have taken all things in double. Now first of all I am finding the distance between both the circles, which it is, and we will see how it's related to us. And now in the binary search I have find the radius. Now for this radius I am checking the distance from, okay, so these things I can like calculate before outside the loop as well, but the first distance is the distance from home to the first lantern, and the second distance is the home to the second lantern, and third one is the office to the first lantern, and second is the office to the second lantern. Now here comes a condition. If these are the conditions. Now the first condition was they should both of the office and home should if they lie in the same circle, then the answer we then they then monograph will be able to go to the home. So this condition is that home inside C1, this is home inside C2, this is home, this is office inside C1, and this is office inside C2. Now if the office is inside C1 and home is also inside C1, that is this condition. If they both office and home are in the C1, then he will be able to go to the home. And similarly for this, if office is also in the C2 and home is also in the C2, then he will be able to go to the home. Now if it is not the case, then if it's not the case, then the condition was they both office and home should be one of the circles, and obviously opposite circles and distinct circle, or we say, and the distance between the home and office, uh, the distance between, see, this is like these are both of them are in the same, both of are in some circle. So that condition is, now we want those two circles to connect. For that we find this distance, and if the distance of the circle of both the circle, like in this case the distance of the circle is this A to B, the straight line, this is the distance we have find. And if and like in this case they are like touching each other, if it's not touching each other, then the distance would not be equal to the twice of the radius. They will be only touching if the distance is equal to the twice of the radius. Then if these two cases satisfy, then we can say we have currently we have the R is able to give us the correct output. And we want, as we want to minimize, then we can say that we are decreasing our E to go to the lesser value of the R. And if none of the condition satisfies, then we can say we cannot find a way to go to the home with this R, so we will be increasing our S to get a higher R. And like obviously we are setting precision to get the answer, because it says like we need to be in 0.1, the decimal should be like correct. Now moving to the third problem. I mean, it's a good problem. It's good problem, but implementation wise I lacked a lot. I was not able to think how to approach initially, but at the end I used a very basic approach to solve it. Yeah, so let's first read the problem. The question is decreasing strings. Now as this is like we all know, I guess we all know the lexicographical smallest string. Like one string is smaller than other in the lexicographical manner. Now, in this question, let me summarize. In this question, we have been given a string s, and uh, they before now we uh, we have been given a string s, and until the size in one operation, they what are they doing? They are removing a character such that the string which we get is minimally lexicographical than the previous one. That is, like in this case, let's see here. Like in this case, if I have CAB, then in the second I will be removing, if I remove C, then I will be getting the minimal lexicographical string, which is AB, and again if I remove B, then it will be minimal here. And now what they did, they concatenated all the strings to get a bigger string. Now what they want, they have given us a position, and we need to find the character at that position of the concatenated string. Now, like if it's 4, then we need to give the fourth output and fourth character, and if I like accordingly we have to give. Now the first question is how can we get the minimal. First question is how can we get minimal string. So graphically minimal string. Now uh like if I have this string. Now in this string, if I remove C, then it would be DBA, which is not a lexicographical minimal string. But if I remove D, then it would be a lexicographical minimum string in that case. But if I remove B, still it won't be a lexicographical minimum string. Now in the first thought, we can say that if removing the highest character would give us the minimal string, but that is not the case. Like let's suppose I have a question string like this. Now in this case, removing D would not give us the minimum string, but removing B will. So if we need to remove first character whose right character is less than current. So in this case, the B is greater than the A. So we need to remove B, because at this B, if we remove B, then at this position it would be A instead of B, which give us the minimal string. Now the question says how can we do that. I have okay, so the approach that I used, I have thought many approaches, but the approach that I use is to use doubly linked list. For this approach, I have used doubly linked list, in which what I am doing, I have two pointers, slow and fast, and slow and fast, and uh, where slow initialize to add and fast is the next one. I mean both of them, both of these characters would be neighbors. Like if it's ith character, then it would be I plus 1th character. And if I I find that slow का डाटा जो है is greater than the fast का डाटा, तो मैं क्या कर रहा हूँ, so I will be remove slow, and in this case slow becomes slow का previous वाला, and I have to like accordingly I have to remove the slow, like in the questions which we do on lead code, like remove a node from a linked list. Similarly, I will be removing a slow pointer, and the slow will be shift to the left. If it's null, then I need two neighbors, then I will be making slow as fast, and the fast would increase to the next one, so to get the two neighbors. Now we will be seeing this in further implementation, but the question arises, how can we find the position? Now हमें post given है, value given है, और हमें position, how can we find that? So as we can see, the first string would be of n characters, and after removing it, the string will become n minus 1, and similarly n minus 2, and so on until 1, and they have concatenated these strings. Now if it's our pos, so the length becomes n, or we can say index, the length becomes n minus 1, n minus 2, and so on. Now, and the pos is given somewhere here. Now to find the position value, what I am doing, I am taking the now we need to find, firstly we need to find in which of the string, like I had n strings, and I need to find in which one of the string my position lies. Like if my n the position is less than or equal to n, then it lies in the first string, and if it's if my pos is less than n plus n minus 1 and pos is greater than n, then in that case it will be lying here. So to get in which string it is lying, I have taken the pref sum, and if I have initialized it as 0, and if I find that some pref is greater than equal to position, my current position, then I am updating the number of, let's have it as num string, let it be f. This is the ith string. Now again I have find that this is in the ith string. The question arises, what character of the ith string? Now for that, if I have initialized the index as pos, if my up that is the ith string where I is equal to 0, that is up is in the first string, then I am not doing anything. It's in the another strings, then what I am doing is pause, and then you can like easily relate to it how it's working. Let me print some values for you as to get what is prep and how you are getting the values. Okay, so let it be we have separator here. Now for this, as its length is 3, then it would be 3, 3 plus 2 and 3 plus 2 plus 1, the positions. Now if my posh is in the first character, that means I need not to remove anything. And if it lies in here, like if my posh is 4, then in that case, if I need to find which index of the ix, which index of the up string, then I need to remove this 3, so it will be the 1. uh, this like the posh is 4, then I need to remove, and the first, that is the first, it would be like this. That means first character of the second string, where this is like this, up and idx. So this is how we are getting which position of the up string. Now as we have got the string we need and the index we need to get answer from, we need to remove the characters. Now as we can see, like here, if I have n if I if my string is first string, then I need not to remove any character from it. If my string is the second string, then I need to remove one character from the original string. And if I am at the second string, then I need to remove 2 strings. So here up is starting from 0 to n minus 1. So if up is 0, then I need to remove 0 characters, and if up is 1, then I need to remove 1 accordingly. So I now here I need to remove exactly up number of the characters from the string. So first of all, this code is about making the string in linked list. So I am making the string in linked list here. Like I have initialized a node, and from I am doing temp to temp next, and I am assigning a new node to it. That is like inserting new node at the end of the linked list. This is like not needed. Now after I made a string, I made a linked list. Now I need to remove the characters from the string such that they are giving me lexicographically minimal string. Now for that, I have 2 pointers, slow and fast pointers, and as the fast pointer is fast, so fast should not be null, and the up, that is the number of character I need to remove should be should not be 0. Like if I have already removed all the characters I needed to, then I should not be using this while loop. Now first is if my slow, as I discussed earlier, if my slow ka data is greater than the fast ka data. Like in this case, if I have this string, then the slow is this and fast is this A. And if the slow ka data, that is B, is greater than fast ka data A, then then that means I have to remove one. That so I'm marking up minus minus, and now I need to remove this B from the linked list. For that, what I'm doing, if my slow का previous, that is B का previous is null, अगर null है, so I need not to so मेरे पीछे उसका पीछे कुछ है ही नहीं, तो मेरे को वो जो बची हुई स्ट्रिंग है उसके पीछे वो कनेक्ट करने की ज़रूरत नहीं है. सो उसके लिए मैंने क्या कर दिया, जो फास्ट है किसी से कनेक्ट नहीं है, फास्ट इज़ नॉट कनेक्टेड टू एनीवन नाउ. एंड जो स्लो होगा, अब देखो मेरे को दो कैरेक्टर्स चाहिए थे. इफ़ आई हैव दैट, द स्लो ये था, फास्ट ये था, अगर मैंने ये रिमूव कर दिया, then the fast is this and I need to assign a slow on the left of the fast. So for that what I'm doing, I'm assigning slow को fast, that is A से assign कर दिया, and fast को increase कर दिया, that is now it is D. And if the slow is not null, then I need to remove exactly that character. Like if this is the case and I need to remove B, then for that what I am doing, I am the fast, that is ये हमारा fast है और ये slow है, तो fast का previous, that is A का previous जो होगा वो slow का भी previous होगा. that is now this A is connected to this A. now इसका जो next होगा, अब इसका जो नेक्स्ट होगा वो B तो नहीं होगा, अब ये होगा, तो उसके लिए मैंने क्या करा है, स्लो का जो प्रीवियस है उसका नेक्स्ट जो होगा वो हमारा फास्ट होगा, और स्लो जो होगा वो फास्ट का प्रीवियस हो गया. अब स्लो मैंने रिमूव ही कर दिया, तो स्लो क्या हो गया, अब ये फास्ट का प्रीवियस हमारे ये कनेक्ट था, तो अब ये स्लो हो गया हमारे पास, तो ये स्लो ये फास्ट, तो ये हमारा रिमूव हो गया. अब अगेन वी आर चेकिंग for these two conditions. In this example, this is going back is necessary, but in this condition it is not. But let me give you some array in which if I remove, going back is necessary. So for that I have used linked list. Now if that data is like same, like if it's A, then I am just increasing both the pointers. Now it might be possible that this condition, that is the previous one is not greater than the next one, that is if this is like case something like this, and I need to remove like two elements from it. So what I'm doing, this will remove no characters from it. So in that case, removing from back is a good choice, as in this loop the slow will go to the end of the characters, like end of the linked list. The slow will have pointed to the last node of the linked list. So now for that what I'm doing, like I don't have head, because it might be possible that my head has changed or removed from the linked list. So first of all, I am taking slow to the first node of the linked list, and after that, I need to I need to get the IDX value. That is the IDX character. So for that, I'm like I'm going next to next to next until my IDX becomes 0. And if it becomes 0, then I'm printing the character at that position. I think that is